Hi, good afternoon, and welcome to the Food Sense Generation Force. We like to do these webinars once a month, and they're really just to kind of give you a more demo experience rather than just talking. If you follow our YouTube channel, you'll know that we're actually doing webinars every week where we answer technical questions. There'll be one going out this Sunday. There was one last Sunday. With that said, let me go forward quite quickly. I just want to just change cameras for a second and just say, this was all about just talking. I've got a Food Sense Generation 4 in front of me here. I've got some chili sensors with me, and I will be doing I'll be doing a quick demonstration of measuring some chili samples. And my colleague Solron, who's online, will also be doing chili and ginger. So you get to see this kind of 3 times, let's say. So that will be happening this afternoon. With that said, let me go forward a little bit quickly. So if you're so interested, you can, because you'll probably be watching a recording of this, scan this QR code on your smart device. It's going to put an app on your phone. It's called Sense It All. Sense It All will ask you to log in, and the first thing you will do then is want to scan a QR code. So first of all, if you've got an Android, scan this QR code. If you've got an iOS, an iPhone, scan this QR code, and then you've got the app on your phone. The app will become apparent shortly, because the first thing that then will happen once you've got the app installed on your smart device, you can scan this QR code, and now you can suddenly see that you're able to, and in fact, that's what I've got on my phone at the moment. I'm able to detect chili. So in a bit, I'll talk it through on this, but this my smartphone will be in Bluetooth connection with the FoodSense Generation 4 product, and I'll be able to measure chilies. If you scan this QR code, you'll be able to measure ginger. So we get less people, let's say, doing ginger, but these ginger shots are kind of quite popular these days. This one actually, I've opened it up, and the ginger roll in it has been dropping off quite substantially. So now it's about 200 milligrams, 200 milligrams per liter. So it's 200 parts per million. So this has got quite the pungency drops off quite quickly once you open up the cap on these things. Basically, the ginger roll is oxidizing. In the food industry, people are always interested in pH. Mind, it's not just the food industry that people are interested in pH. I think pH is the most measured parameter in the world, chemical parameter in the world. Total antioxidative capacity. We do get asked about this. You get plenty of companies doing nutraceuticals. So if you do a nutraceutical, you'll see high in antioxidants. But actually, there's never any kind of measurement on these. So total antioxidative capacity. It's one of the best sensors we got, and that will measure you how many antioxidants you've got. It's a predictor of shelf life, and it's also a predictor of freshness as well. So TAC is useful. Glucose, how much glucose and sugar is added to food. So glucose is also on the Food Sense Generation 4. What does Food Sense Generation 4 offer you? It offers you rapid test. So you'll see that kind of rapid test, let's say for real, during this particular webinar. And you will also see us doing, when I say cost per test here, let's just remember that when we talk about cost per test, the thing about measuring either capsaicin in chilies or gingerol in ginger, for example, it's actually quite expensive to get those tests done. If it's capsaicin, people are using an HPLC machine. An HPLC machine will cost something like $50,000. The Food Sense Generation 4 is not even it's just a tiny fraction of that cost. And the cost per test is, I've got a row of sensors here, but each one of these sensors is about €2.50 each. If you're using, and you're clever with the use of the buffers, you're using less than €1 worth of buffer each time. So this test should be costing you less than easily less than €5 or $5 per test. We would call this an objective test, and what do I mean by that is you will definitely see it. I'll do a quick test where I actually show you the objectiveness of this, and what I mean by that is the data will actually go to the cloud. So even though you can get a raw number, not raw, but you get a number on your phone that says Scoville heat units X, for example, 5,000 Scoville heat units, for example. We'll also be able to show you that we actually have the capsaicin fingerprint stored in the cloud. So if you're a quality manager and you're ever challenged over, well, that's all very well, but give me the evidence. Then you'll find that you've actually got the evidence saved up on the cloud. That objectiveness is also that transparency that actually we always save the raw data. So you can have an operator in your facility getting a very simple answer that they can just write down. but then you can actually log into the cloud system as well and actually see the raw data up there as well as the number. When I say that transparency, see, if you're using if you're using an HPLC third-party service, it's probably costing you in India $25 maybe per test. In the cheapest that you get it in the US is maybe $50 per test. Typically, I think globally it's actually about $100 per test. And for that, you may get an email with a result, or you may get a certificate of analysis. I saw a certificate of analysis on a YouTube channel the other day, and it was like 66,000 Scoville heat units. I thought, what's the probability of something being exactly 66,000 Scoville heat units? I tell you what, the probability of something being exactly 66,000 Scoville heat units, very improbable, actually. So I'm a bit suspicious of these certificates of analysis, but that said, there's no transparency on them. It's just a number and a piece of paper, and people say, "Oh yeah, okay, that must be right." Well, what evidence do you have of that? And that's why the Food Sense Generation 4 actually saves the data to the cloud. So it helps with traceability, it helps with quality control, IQC, PQC, process quality control, and OQC, outgoing quality control. So it does, and I think something that is actually quite useful is you can actually blend your product to the required spiciness or the required hotness. If you've got the Food Sense Generation 4, you can follow process in real time, which you just can't do on something like an HPLC system. You'll see it. In fact, I've got a few samples here today. I've got this kind of blended up chili, for example. We've tested things like spicy mayonnaise, very nice from Hellmann's. It is quite spicy. It's only about 2,000 Scoville heat units, so it's quite mild. Nando's, popular chain of restaurants in the UK, they do their own sauce. We have tested the Nando's sauce. We have tested chili oils. I've got a chili oil here. The reason I'm bringing all this up is because, unlike a lot of technologies out there, this is really very good at dealing with quite complex matrix, from just chopped up chilies through to chili sauces, through to honey. It's a very tasty honey that also has capsaicin in it. The bomb is also on there. So there's there's lots of hot sauces out there, but this is one of them. It's got one of the reputations for being one of the hottest. I've got a suspicion that they're actually augmenting it with capsaicin in some way. Maybe they're using an olea resin. And I should mention that as well, that we were testing olea resins recently. In fact, that was happening in Indonesia through the reseller in Indonesia, and they were coming back really quite hot. If you're in the industry, you'll know what I mean by an olea resin. If not, they're a very concentrated tarry material full of capsaicin. This is called Psycho Sauce. I've been slowly getting through this bottle of Psycho Sauce for the last few weeks. So we are testing, this is chili powders. And then I think the last one here is actually measuring ginger. So that one's a little bit different. So we are able to deal with a whole range of products. People ask us, can you deal with this? It's like, yes, we can deal with it. And you'll see why we can deal with it actually when we do some of the testing, especially the testing that Solron will do in a bit, because you'll see there that we are preparing the samples. Just to give you a quick introduction to ZP, ZP is 10 years old. Well, we'll be 10 years old this November. We are ISO 13485, so we follow one of the strictest, I want to say sort of one of the strictest quality systems out there. It's interesting actually, because people ask us about kind of quality, and it's like we're most of the time making medical diagnostics, you know, that are intended to kind of prevent or protect human life. So making chili sensors is actually a lot easier than let's say the day job. But I will well, you'll see some of that today, let's say. Team is quite big. I'm very international. Something like 20 languages are spoken within the company. Just to say, if you do become a customer of Food Sense Generation 4, you will get personal online training. I mean, the beautiful thing now is we live this world of great connectivity. I've got a Food Sense Generation 4 in front of me now. It's very easy to kind of start demonstrating actually how to run this device. So we are able to give personal online training, and so anyone who's bought one, you come online with us, we give you some training, you do it in front of us, and we can sign you off that you're trained. It'll come up in a little bit actually, but I also want to bring up the fact is that this system is actually really quite simple. This is the manual. This manual is not super thick, and it's not because it's lacking information, but it's actually just because the technology is actually quite straightforward. I think, and it's also kind of nicely illustrated. It shows you the QR codes in order to install the app. It shows you how to turn the meter on. There's two buttons. You press a button and it turns on. So that's actually quite straightforward. Um, Teaches you about how to scan the QR code. Teaches you the screens. There's not that many screens. Teaches you how to add the sample, which will do in front of you anyway. And then shows you that the data's uploaded to the cloud. So why is this slim? It's slim because actually this is quite super simple to use. Why is it super simple to use? Because actually one of our sort of things that we do at Zimmer and Peacock is actually make glucose strips or help make glucose sensors for diabetics. And there, you can imagine the user experience is very simple. So we've really thought about the user experience. There are weekly webinars. There's a webinar this Sunday when we'll talk about some chili powder testing that we've been doing with clients in India. We have monthly webinars. Welcome to the monthly webinar. Lovely to have you. Just to say, Food Sense Generation 4. Now, Generation 4, this is what Generation 1 looked like. So every kind of generation, we've taken the lessons, that we learned first time round and then, made Generation 2, Generation 3. And I think we're sort of hitting some sort of pinnacle of performance at this point. We're really proud of Generation 4. One of the big differences with Generation 4 is actually on this little list here now. So I will go through it. Let's say that the unit is smaller. I mean, if I just put my hand onto the unit just really quickly, you can see, that it is quite small. I know I've got big hands, but the unit is very small. It's easier to use. This, in fact, on our YouTube channel, you may find a 6-year-old and a 10-year-old doing a demonstration on this unit, and it was unrehearsed. So it literally is child's play. It's more accurate. The accuracy really comes from, this is the bit that makes me weep with joy, because actually the data goes to the cloud. So if there's a problem, you can have a wrong reading, which will therefore be not accurate, but we can see the raw data, so we can always troubleshoot really easily. So that's thanks to that cloud enableness. It's multi-analyte. We can go between different analytes just by using different QR codes, chili, ginger, and total antioxidative capacity. You'll see me using the hardware today anyway, so this kind of video is, I wouldn't say so much superfluous. You'll see Solrun do a little demonstration shortly. There's no PC required on this particular device. Well, it's just no PC required, full stop. It's actually run off the smart device, and you'll see us scanning QR codes, and QR codes is what tells the little meter exactly what to do. With that said, this is what it looks like. Now, if you were to get hold of one of these units, this is the kind of, this is the boxing, just to give you a sort of a sense of it. This is what the box looks like. What comes in the box is buffer. So you'll see us use this buffer in a minute. I'll talk about dilution in a minute. So we dilute samples in this. This is 500 milliliters of buffer. First thing you can obviously notice when you open up the box is there's a manual that comes with it. And there's also the meter itself. There's also the sensors. In fact, I've got some sensors here. So you get 100 sensors. Here they are. We snap the sensor every time we need one. So you get the sensors in rows. And there's also there's a cable as well, also for power. So you get a lot of things in the box. You may see us use pipettes and vortexes this afternoon. The pipettes that we're using, we're just getting these pipettes off Amazon, so they're really quite low cost. And the vortexer that I've got a vortexer here now, and Solron will use one as well. I've got my vortexer off Amazon for something like $50. They're really not super expensive to get the kind of little accessories that you'll see us using this afternoon as well. As I say, you can scan, if you're watching a recording of this, you can scan this QR code, and that will put you can scan that off your Android phone, and that will put the app on your Android phone. Or if you've got an iPhone, this is much more of a California thing, let's say, you can scan this QR code off your iPhone, and that will put the app on your smartphone. And if your smartphone, that will make Bluetooth connection with the device itself. So you can then later on scan chili, that will do chili, scan ginger, that will do ginger, pH, total antioxidative capacity, glucose, etc. So the sensor will go into the meter. The meter is told what to do by the app. The app will run the assay. The meter will give the data back to the app, and the app will show you the result, and it will also store the data on the cloud as well. Now, what I might do now is just do you a quick demonstration of do is I'm just going to stop sharing my main screen and just bring my phone in. So at the moment, I've got the app on my phone. I'm in Bluetooth connection with this particular device. I've actually got a fresh sensor on here, but it's easy enough to put a sensor in. There's no slots or alignments or anything strange like that. So the sensor's in there. I'm going to take a sample. So I've prepared a little sample here. So I'm just going to quickly pipette some sample out. I'm going to put 50 microliters on of sample onto the sensor. Just to say, it definitely says it in the manual to put 50 microliters. I put that exactly, well, let me just have a quick think what I'm actually doing. Yeah, here we go. Rather amusingly, I had the same problem. I think Soren was having this problem earlier on with one of her pipettes as well. So, right. So I will check the name. Name is fine. I will go to assay. I did what's called a 1 in 100 dilution, and I'll explain that in a little bit. So now there's a progress bar on the front of my app, and there's also a flashing LED here as well, which is flashing away, and that's telling me it's like a status of the machine, that the machine's actually running. But I've also got the progress bar running here as well. So that will that's giving me two indications that actually this is let's say running. So let it get to its end. So you can see that the assay itself is quite quick, and it's come back with a Scoville heat unit of 7,632. I'll just change cameras just for a second. Whoopsie daisy. So I'll just show you the result on my phone. I realize it's a bit bright, but then I will also just share my screen with you for a second as well. So let me just share this, and I will just refresh. So every time we do a result, it actually sends the data also to the cloud as well. So I can see it here. And this is the bit that I was very keen to kind of say, that we in part get the accuracy because actually we can see the raw data up in the cloud. In a minute, I'm going to talk to you about, I'm looking now, I'm not expecting everyone to become this kind of electrochemist. You can have a nice simple result just on your phone and you can write it down. But you may actually be scientifically curious, or you may want to be, ensuring that, these results are for real. I mean, how many times do you get a result on something and you say, oh, okay, that must be real. Really? Really? Is it real? I mean, so what we're looking at here is, I'm going to explain now in my next part of my presentation that, in fact, what we're looking at here is these peaks here, peak here, peak here, and peak here. We call this peak 1, we call it peak 2, and we call it peak 3. But I am going to actually, let's say, run through that in the next part. So I wanted to just show that part. You'll get a more detailed demonstration from Solrun, but I just wanted to emphasize the point, which is you will get a result on your phone. So there's no need to become an electrochemist, but is also worth knowing. Actually, it's a really important part. I think it's one of the few, let's say, instruments out there that actually will save both the result in the cloud and the raw data in the cloud as well. And that gives you transparency, which I really don't think exists in otherwise. People are using these kind of HPLC analysis. There's no transparency. If you really, well, I'm sure many of you do understand HPLC, but there's actually what they call a chromatogram, is the raw signal behind an HPLC, but you never get to see it. And if you ask for it, they probably simply don't have it. So the Food Sense Generation 4, now this is the reason we can talk about this in openness, is because that's actually patented. So patents are great because then it means you can be very transparent with people about how it operates. It originally came from the University of Oxford. And now the molecule that's obviously gives you the hotness, the sensation of hotness, is capsaicin. just for a second. I forget what the receptor is called. I want to say TRVP1, but I've got to check that up. I'm not. It might be called TRVP1, but I have to really that acronym I have to check. But capsaicin. Now I was kind of saying, oh well, I was interested because I got the raw signal in the cloud, and there were three peaks. There's peak one, which I was talked about. Then there's going to be in a minute. Now, when you're watching that progress bar on the app, it's literally doing this experiment, but people don't want to see this experiment, but that's peak two. But it's doing that in the background. But you do actually get to see the raw data from the test because it's in the cloud, and that's peak three. Now I want to talk about those peaks. They're not just random. They mean something. They mean this is capsaicin, and the intensity of the peaks, how much capsaicin there actually is. So when we're doing this, we start off with capsaicin in the test. We do what's called electrochemistry. You'll hear Solomon. Solomon's favorite phrase is cyclic voltammetry. So you'll hear that mentioned a few times, but we're using a technique called cyclic voltammetry, and we're detecting the capsaicin on our sensor. And this first reaction gives us what we call peak one. So this is peak one now, just appearing here. And I might just actually I'll go on. Then there's another reaction, which is called a hydrolysis. So we get peak one, the molecule in peak one then hydrolyzes. There's nothing we could do about it. That's a good thing because it's part of the assay. It forms a new molecule, and then we actually get a peak we call peak two. So there's a new, let's say, reaction that gives us peak two. So that was peak one, which we get first, and then we're studying the system more, and then we get this new peak. Here it comes. That's peak two. So that's the second part of the fingerprint. The fingerprint for capsaicin has three elements in it. And then the final element is we're looking for something called peak three. So there's another reaction at the end here. So that's peak one. That's the first indicator. This is capsaicin. You can understand how specific this experiment actually is, because it's very hard to have these kind of peaks in this order, other than it actually being the molecule of interest. And then we get what we call peak three, and that's our confirmation. So you can understand that, we're analyzing this is what the software is doing. We're analyzing these peaks and then quantifying their area under the curve to say how much capsaicin is actually in there, and that's peak three. Something that I do talk rather quickly over this, but we if you think you may not know what your Scoville heat unit rating actually is, and so if you're dealing with Carolina Reaper chilies and they're wet, then their Scoville heat unit might be about 200,000. If you're dealing with Carolina Reaper powder, then maybe there's Scoville heat unit on that is about 2 million, because it's been dried down and desiccated. If you're dealing with De Bomb, it's 135,000 Scoville heat units. The reason I bring this up is because often actually we do have an approximate idea of what the Scoville heat unit of a product will be. But if you don't know, the app, when you first run the app, if you dilute too much or you don't dilute enough, the app will definitely tell you. But the reason I've got this up is if you think your product is in the range 412 Scoville heat units to 10,000 Scoville heat units, then we'll probably tell you to do a 1 in 10 dilution. If it's 4,000 to 100,000, we'll probably tell you to do a 1 in 100 dilution. If it's 40,000 to 1 million, we might tell you to do a 1 in 1,000 dilution. And if it's 400,000 to 10 million, we might tell you to do a 1 in 10,000 dilution. Why are we telling you to do this? Because the buffer that you're preparing your sample in, and you'll see Solron do a sample prep in a minute, is an aqueous buffer. It's water. It's water with extra things added into it. But capsaicin is an organic molecule. So capsaicin is not terribly soluble in buffer. So how do we overcome it? We overcome it by increasing the dilution. But the software is clever because it will ask you what the dilution factor was, and it will back calculate to give you the original Scoville heat unit concentration in the sample. So you don't have to do any maths. You just have to tell it what dilution you actually used. So that's why I've got this table up here, just to kind of indicate that, A, it exists, and B, why does it exist? It exists because the natural solubility of capsaicin in aqueous solutions is about 500 Scoville heat units. The reason you get things hotter, like this oil, is because oil is organic and it's very good at dissolving organic molecules. So that's the kind of rationale what's actually going on there. I say here demo. So what I'll do then is I'm going to mute myself, turn my camera off, stop sharing. My colleague Solron will kick into action. Hi, Solron.
Hey, yeah, so I'm Solron and I'll run you through a couple of demos. So today I will be testing a ginger shot and a chili sauce. So let's start with the ginger shots. I'm just gonna vortex that just real quick, just to make sure that the shot is homogeneous and that we get a representative sample. So I will show you what the app looks like. So here is the app. Right now, we've scanned the QR code for the ginger assay. So it says ginger sensor has all the settings that are related to that assay. And then I have the test settings where I've already written the sample ID saying ginger. And then I will click go to assay. And the app will tell you what to do. So here are the instructions telling you to place and lock the cartridge, and the cartridge is the sensor. So we will place that onto the device just like that. And then the next thing, according to the instructions, is to mix the sample well. So we need to prepare the sample, and in order for us to do that, we need a dilution ratio, which Martin was talking about. So we know that this ginger shot is not that pungent, so we will make a dilution ratio of 1 to 10. So 1 part ginger shot, 9 parts of the ginger buffer. So I will pipette 900 microliter of the buffer. So 900 microliter of the buffer, just like that, and then 100 microliter of the ginger shots. So I'll show it to you and do it online just so that you see that I'm not cheating and just how easy it is to prepare these samples, in fact. Okay, so here's the vial, and I'm adding the buffer just like that. And then I will add 100 microliter of the sample, right, like that, and then you can see here, so it's in the pipette. I'll add it to the vial. And the ginger sample is quite liquidy, so it mixes really well. But regardless, we will use the vortex just to make sure that we have a homogeneous solution. And since this mixes so well in the first place, we don't need to vortex it for a long time. So here you see that we have a homogeneous solution. So the next step is for us to pipette 50 microliter of this mixed sample onto the sensor cartridge. And we will pipette it onto the sensing area of the sensor. So let me show it to you up close, just like this. And then I'll also put the phone in view, just like that. And then I've adjusted the pipette to 50 microliter, and then I'll cover the sensing area just like that. And then I will click start measurement in the app. And I will show you the screen like that. It shows you a progress bar. So rather than showing you the raw data for me, the cyclic voltammograms that Martin was showing you, it shows you the progress bar. This is simplified outlook on the data. It will give you the numbers back without the raw data. And then to look more in depth, you would go to Julie, the on-cloud platform that I will show you later. So the test is wrapping up and we get results back for molarities and milligram per liter, which are the relevant numbers for ginger. So, and it also says upload complete, which means it has been uploaded to Julie, which I will show you now. So Julie, I need to refresh the page just so that it will load up the latest sample. So I'll click it. And here it is. You see the first scan up here and then the second scan down here. And here you can see the different peaks and which peak it's assessing, just to determine what the concentration of the gingerol in the sample is. You can also go into the edit mode and see further what kind of settings we have applied to our sample, and just to measure the sample itself. And we can also add in extra details just so that it's easier for you to sort through your data and see what you've previously done. So here are just my initials, and it also states the date, so that that can also help you sort out your data in case you didn't label it. So then we will continue with chili testing. These sensors, though, are one-time use sensors. So we will dispose of the sensor and add a new one. The reason why they're one-time use sensors is because these sensor or these organic molecules very much like the surface of the sensors. So it will attach to the surface, hence one-time use. So we'll click done, and we need to choose that chili assay. In order for us to do that, we'll click the button right next to ginger sensor. That gives us the possibility of scanning a new QR code. So I'll scan the QR code with chili sensor. So now we've chosen the chili assay. So we'll change the test settings to reflect that. So we'll write Apollo instead, which is the name of the sauce we're testing. And we'll click go to assay. So this sample in particular, it's very pungent. So we will make a dilution factor of 1 to 1,000. So I'll click the 1,000 dilution factor, and then I'll start preparing the sample. So in order for us to make a 1 to 1,000 dilution factor, we will use 40 milliliter of the chili buffer and 40 microliter of the sauce. So that gives us 40 versus 40,000. So I'll just shake it a bit just to make sure that we have a homogeneous sample yet again. And then I will add some into a weighing strip just like this. So I'll just, it's just so that it's easier for me to pipette it later on. Just like that. And then I'll go to this view again. So change the pipette to 40. And then I need to add 40 milliliter of the chili buffer. So just like this. Okay, 10 milliliter. So Martin was saying that sometimes we test samples that are way more chunky, or even we test powders. But now you see these samples, they mix really easily. But if we have chunky sauces, they might not mix that well. So what we would do then is just give it a bit more time on the vortex, and maybe also allow it to rest on the bench for a while, just in order for that capsaicin to be extracted from those chunks and pieces into the solution we are testing. So now we've got 40 microliters. Also, if we're testing chili fruits, what we just do to cheat is to just make sure that we dice it up real nice and easily. Then then it's easier for the capsaicin to be extracted more easily. Okay, so now I will just pipette 40 microliter of this sample. I will show it to you. So here you see, there's 40 microliter of the chili sample into 40 milliliter. So just like that. And then what you can see now is that it fell down to the bottom. So we'll just vortex it for a while just to mix the sample well yet again. Make sure that we distribute this sample into the solution. So here you see it's homogeneous in the sense that it's not fallen down to the bottom, but if you would zoom in, you would see that there are some chunks and pieces in there, some chunks and pieces from the chili itself. Yeah, you actually might see it floating around there. And don't worry about that. The capsaicin is being extracted from those chunks and pieces into the buffer. And it doesn't matter as well if we add those chunks and pieces onto the sensor. It's able to read through those that buffer regardless. So now I will pipette 50 microliters yet again onto the sensing area of the sensor. So here I have the sample, just like that, and then I just need to add 50 microliter onto the sensing area, just like that. What is really neat about this design of the cartridge is that if you spill, it's really easy to clean the device itself. Okay, so I'll click start measurements and the progress bar will start running for about 30 seconds. So yeah, we have designed this device in particular with that in mind, that we're in a lab environment, or we might be in a fabric or a factory where spilling might happen, and we don't want that to intervene with the electronics. So we've designed it so that the pins are coming down, and if you spill, you'll just wipe it off and it's ready to go right away. So we are using these on a consistent basis. So we've also made sure that they're easy to use. So here we got the results back, and it says that we have a Scoville heat unit count of 41,000, and it also gives us back the numbers in molarities and ppm, which is relevant for the chili testers. So let's quickly have a look at Julie. So we'll go to Julie and I'll click refresh. Here the Apollo data pops up, and we can see the first CV scan and then the second cyclic voltammogram, where we see the peak, which was assessed, and also it gives you the molarity and Scoville heat units yet again if you don't have your phone screen next to you. So back to you, Martin.
Yeah, well, thanks, Lauren. Nice demonstration. Appreciate you preparing the samples in real time like that. So yeah, nice job. And I think also we kind of, the food sense generation 4, you can see, it's actually quite intuitive. It's quite easy to train, which I think, is why, the manual is quite thin, because actually when you watch us do it, 3 times like that, then you start to get a really good sense of how it works, and then you can always confirm that everything's working by just looking at the raw data up in the cloud. Like I say, we're not trying to make you some sort of electrochemist. We're just giving you the kind of confidence that you know what you're looking for, so you can get your result and say, okay, all right, well, that looks interesting. How do I know that nothing went wrong? Well, you go and have a look at that very distinctive raw data in the cloud. And when Solron was doing that Scoville heat unit, it was the actual number was also up in the cloud as well. So we're gonna post this recording online shortly. We will send you a recording. If you're watching this live or you're watching the recording later on and you have any questions of ZP, don't hesitate to reach out to us. But as I say, if you're attending live today, we have your email. I'll send you an email link very shortly. And if you've got any questions, you can just respond to that email link. So special thanks to Sol Run, special thanks to our guest this afternoon. And as I say, if you've got any questions, watch out for an email from Martin very shortly. Okay, take care. Have a good day or have a good evening for my colleagues in Norway. Okay, take care. Bye-bye.